Hi and welcome everybody to Spamhaus's webinar on Blocklist Basics, a refresh for you all. My name's Sarah and I'd like to introduce you to Manuel.
Good morning.
And Carol.
Good morning.
Now, Manuel, otherwise known within the industry as Skull, he's been working with email infrastructure and particularly the security aspect of email for more years than he'd probably care to admit. And Carol's been with Spamhaus for over a decade. He spends most of his time investigating how a bad actor's infrastructure operates, making sure that the internet is a safe place for users and protected from nefarious activity. Carol's focus is predominantly around the reputation of internet resources. Now, just before I hand over to Skull and Carol, I'd like to mention that we will be having a Q&A time at the end of this webinar. So we've opened the Zoom Q&A window. Feel free to put your questions in there, or alternatively, you can send them through to me in the chat. We won't ask them as they pop up though. We'll get to the end of the webinar and then we'll go through any questions you might have. And now I'll hand you over to the more than capable Carol.
Thank you, Sarah. So before we start, let's cover what we'll do today. I will start with the name of what we're going to talk about, because there's usually some confusion around it. We'll look into what actually is a DNS-based block list. We'll look at how we compile the list that we publish, how we come to the policies that we use, then how to use the list that we create, how you can integrate them into your existing systems and workflows, and we'll look at what kind of data sets we have available right now. So let's start with what's in a name. There's a whole bunch of different names that are being used. You'll see block list, blacklist, real-time black hole list, DNSBL, and what is the right name? So, and what are we talking about? In the end, it's basically all the same. They'll refer to the same thing. What really matters is that we talk about the same thing here, and it is a data set that we use to help us assess the reputation of something that tries to send email, and what we usually call them DNSBLs, because the most common way that people use them is through doing a DNS lookup. And so the data is published in a zone file format and consumed by doing a DNS lookup. Now, that does not mean that that's the only way of doing it, but for now, when we talk about block lists, this is basically what we usually refer to. And that is basically the most common way of using the data in an email environment. And to explain a little bit more about how that works, Skull will take that one.
Thank you. Yes, as a matter of fact, as Carol said, we're giving a lot of different names to what is actually exactly the same thing. So where does the name DNSBL come from? Well, it's just a combination of two things. The BL part, of course, it stands for block list. That is just a way to describe what is basically a database composed of resources you want probably to block for any definition of block, as we will see. And the DNS part is simply because it can be queried using DNS as the interface. Of course, again, this is by far not the only way to query it. As a matter of fact, we do provide the same data through an HTTP interface as well. It's just that historically, mail servers have supported doing this type of lookups over DNS for more than 2 decades by now. It has its own advantages, particularly the fact that the media is firewall friendly. meaning that you don't need to usually open any port on a specific port from your mail server in order to be able to consume the data. You just need to be able to do a normal DNS resolution, and the answer will come. In addition to that, given that DNS is being used as the transport media for these queries, we also gain the caching abilities of DNS by default, meaning that we don't need to integrate those features in the protocol we build. Same for the redundancy. In case one server is not available, the DNS protocol will simply ask another one. So this simplifies things for under a number of aspects. It is also a relatively low latency way of asking for information, because DNS, as you know, is transported over UDP, meaning that you don't need to open a connection to get an answer to your question. And that is why it's still so much in use. Now, as we said, this is just media, but what you query through the DNS lookup can be more or less anything that fits DNS as the transport protocol. And as a matter of fact, right now, you can find implementation of this concept, listing anything from IPs to domains and host names and to other things, and as we will see later on. Some clarity should be put around the meaning of block in the name blocklist, because as a matter of fact, DNSBLs do not block anything on their own. They will just receive a question and they will answer with a numeric code. The meaning of such numeric code is, of course, depending on the policies of the list that you're querying. But it must be clear that any action that is going to be undertaken as a result of that response is going to be entirely in the hands of whoever does the resolution, does the query, that is the mail server owner. You can decide to reject the message, you can decide to tag it, or you can decide to do anything you want. In the end, it's entirely in your hands. So this is basically what a DNSBL is. Of course, building it means doing data collection, then deciding what makes sense to compose a list of, and finally, only finally, build the list. So let's go through how we collect the data first, and I'll leave that first step to Karol.
Thank you, Joel. So, like you said, before we publish anything, we need to actually create the data set. So for inputs for the various lists that we have, there's a lot of work goes into that. And we look at, obviously, we look at our own spam traps and honeypots. We look at large quantities of real email flow. So not just spam, or actually real email that legitimate senders send to each other. Person-to-person communication, anything email. We look at all sorts of the aspects of sort of the traffic flow of email from a DNS perspective, from the domain perspective, senders, IP addresses, anything, basically any data that we can get that helps us to clarify what we see, to put context around what we see, is beneficial in determining the end result, which is actually, even though we usually refer to it as a block list, what our lists actually are just lists of reputation. So we have lists with IPs that we think are doing bad behavior, which have, as a result, of bad reputation. For some of the data sets, this actually results into having not just the usual black and white scale available, where we say, so if it's in the list, it's bad. If it's not in the list, it's good. Internally, and exposed through other means than the block list itself, there's a reputation scale where something, it might be good but not super good, or it might be bad but not super bad. So a lot of data goes into that. And because of that, there's a lot of cooperation that we have with other ISPs, with registries, industry working groups, organizations like ICANN and other researchers that look into the various bad things that are going on online, and that in the end allows us to create the data that we do. Now, all that raw data that comes in is given the volume, there's basically only one. The only way to deal with it is to have a lot of automation in place. So there's a lot of heuristics being applied to various data sets. There's machine learning involved. There's manual investigation involved. We take pride in that we have a really good team of researchers who are able to apply their own expertise and experience to the data that we have. And the end result of that are the data sets that we publish for consumption. And a lot of data goes into that, and Skull will tell you a little bit about that.
Yeah, specifically, mostly about the sheer number of analysis we run, because that should probably give you a perception of the amount of work that is involved in doing what we do. As a matter of fact, these numbers change more or less continuously, partly as a result of just the number of data points that we analyze that keep increasing. But as we add more capacity to process them, but also because, of course, over time you decide to apply new types of analysis, and that, of course, increases the amount of things you need to do. So right now, for example, and this is something from this week, basically, on busy hours, we're processing something like 150,000 SMTP connections per second. A few thousands of those are actually involving full messages, meaning that specifically it's traffic that is being received by our spam traps. So it's actual spam that we can see in its entirety, and not only in the metadata that identify it. And this allows us to identify and evaluate, for example, new domains as soon as they are in use. As well as sending IPs, as email addresses that are being used by some scammer, for example, or anything that involves the content of email. It gives us a pretty good overview of what is going around. Of course, a lot of our work, and actually of Karl's job, is exactly about finding new ways to get more data, to do better analysis, to get a better insight about what's going on. It must be said that what we do is by far not limited to email and spam. One of the things we do is, for example, running our own malware analysis farm. We do both static and static and dynamic analysis of binaries, whatever their source is. This is mostly to identify and therefore list botnet command and controls and distribution points, as we'll see later. We run our own botnet sinkholes that allow us to identify bots, Trojans, and other threats that are not involved in the email spectrum. We run multi-protocol honeypots, including IoT type, to collect data about generic threats that may be going up. We run a very active and passive DNS data collection. That is one of the ways we collect information about new domains even before they are registered. As long as they are seeing use for anything, we try to identify them. And this is not everything we do, of course. This is just a small description of some of the things we do. And of course, all this amount of processing of data goes through the filters of our policy decisions in order to build lists, as Karl will tell.
Yes. So one of the things that I think is very important to us and to our users is the policies around the data sets that we publish. We don't just throw anything in there that we would like. Every data set that we publish has a very clearly defined policy of what we put in there, what our users can expect to be in there, what they what would not be in there. This is these listing criteria basically sort of drive the research and the methodologies that we use to collect the data and to put it in there. In the end, I think we think it's very important that each data set has its own clear place in the entire process and its application. These policies have been defined over a long period of time. Obviously, they're not set in stone, as in, if it needs to be changed, we'll change them. But most of them have been in place for a long time, and it's by now it's quite clear that for our users what to expect when they apply our data to an email stream or to something else. And but it's not just us that defines these policies. We have a very long history of working with the industry, with industry stakeholders, with working groups like MOG, for example, where a wider subset of the industry comes together and people discuss what is useful to have and what would be good to have and what is the right way of doing something. And so over time, a lot of our policies have really been formed by interacting with our users and working for the internet and with the internet. And the best example of that, I guess, is the policy block list that we have, the PBL, which is one of our most well-known data sets. And so the IPs in there, or the IP ranges basically that are in there, the idea behind the PBL is to have a list of IPs that shouldn't send email directly to a mail server. So these would be any end user IP ranges like DSL or cable ranges, mobile, 3G, 4G, 5G, anything where you expect end users to be who would, in a normal situation, when they want to send an email, they will submit that email to their providers or their corporate mail server. And from that mail server, it will go on onto the receiving mail server. So no email will be directly sent from that IP space. Basically, all the email you usually get from IPs like that is the result of some sort of compromised device. So there's a really a good incentive to not accept email from those spaces. Now, the thing that makes our data set unique in the industry with that is that we manage it together with the network. So for the PBL, a network owner can come in and they can create a management account and add the ranges themselves, because in the end, the philosophy here is that there's nobody who knows the network better than the network owner, and they should be the party that's best able to tell what parts of the network should be allowed to send mail and what not. So for over a decade, we've been managing the PBL together with thousands of network owners who add their own IP ranges into the PBL. They're able to publish their own policies for their network ranges and inform end users who might run into a PBL block, what they expect them to do. And this is a really, I think this is the best example we can give of how it's not just us sitting there and saying, okay, this is what we're going to publish. This really is a cooperative product where we work together with the broader internet, with the industry, to create a data set that is has a really good use for the entire internet. But that is just one of them. And as far as IP data sets go, the PBL definitely is the one that has the most number of IPs covered, but there are a whole bunch of others, and Skull will go into that.
Yes, indeed. Carol already covered the PBL. That is just one of the data sets that we publish. Historically, the very first list that the Spamhaus project came up with was the SBL, the Spamhaus Blocklist. This Spamhaus Blocklist is manually curated, meaning that it's every entry that is added to it used to be created manually and edited manually by one of the researchers behind the project. It was thought so that it could list any network size, meaning that it could be just a single IP or an entire subnet if that was deemed necessary. And its main characteristic is that it is thought to, first of all, inform the network owner of what we're seeing and the problems we are seeing, because the end goal for the SBL is not only allowing consumers of the list to block stuff, but also notifying the existing of a problem to the network owner so that the problem can be remediated. Of course, doing this type of listing manually is not really going to scale much. So at some point many years ago, an entirely automated component was added to the SBL. It has its own numeric code, so you can distinguish between the manual ones and the automated ones. And it's called the CSS. We're not going to step into what it means because I think it was forgotten a long time ago. But its main characteristic is that it's going to only list single IPs. It never lists ranges, at least not in IPv4. It does so in IPv6, mostly because the minimum granularity for a listing is a /64. And its main characteristic compared to other lists that we publish and that we'll see later is the fact that it only targets SMTP emission, meaning that whatever ends up listed by the CSS is listed because of some SMTP activity that triggered our heuristics, our policies, basically. This is not necessarily the case for the SBL at large, meaning that the manual component was thought to be extremely flexible. It allows us to list an SMTP emission as well as botnet command and control, for example. So there is that difference into this, and this has some implication that we may discuss later or maybe not. The second component that we want to talk about is the XBL. The XBL stands for Exploits Blocklist. It is a list that is composed only and solely of machines of public IPs showing signs of compromise. Just like the CSS, it lists IPv4 down to the single IPs, never a CIDR. It has the same /64 granularity for IPv6. It is not limited to SMTP emission, meaning that this is actually generated starting from very many different indicators of compromise. Some of them may involve other protocols that are not related with SMTP. And as a result, even a machine that is not capable because the traffic is blocked to generate SMTP traffic can show up in the XBL. Then we have yet another list that is the OAuthBL that is generated as a subset of the XBL mostly. And this is a subset of the compromised machines that we observe that we know are either capable or actively doing abuse of SMTP credential. Good examples are bots that are known to rely on stolen SMTP auth credentials in order to send out spam, or sometimes it's
compromised systems that do scan the internet, trying to brute force for SMTP credentials or other type of credentials in order to, again, break out spam and stuff like that. The difference, the reason why this exists as a separate entity compared to the XBL is the fact that this is specific enough to be used in, for example, deep header parsing, or to be used in an MSA, in a mail submission agent. Meaning that we do not encourage the usage of the XBL at large to block stuff that is trying to access your SMTP auth in order to send out email. The AuthBL can be used and should be used in that fashion. And in the end, this is what I think what you would need to keep in mind. That is, not all the lists are the same. What defines them are the policies. The policies mean different things and allow for different types of usage. So some of them can be used, for example, in deep header parsing, as we said. But a good example of something that cannot and should never be used in deep header parsing is the PBL. I mean, an email must be generated somewhere, and that somewhere is usually on end user IP space. So doing deep header parsing against the PBL doesn't make any sense. So understanding what should be used and in which situation is paramount in order to use our data properly. We published a lot of stuff exactly on this topic. I encourage you to take a look at our documentation if you want to. Another option, if you don't feel comfortable with starting from scratch, would be using the rule sets that we already provide for example, spam assassin and rspamd, that are already integrating the lookups against our various data sets in the right place, so that you can start from something that, in our opinion, makes sense. But of course, you are free to build your own implementation. And that's about the IP block list. There are other block lists that we publish, and Karel can go through the first of them.
Yes. So besides putting IPs in a DNSBL or in a data set, when you talk about mail, there's another internet identifier basically that is really basically seen in every email that you get almost, and that is a domain name. And so we have a data set with bad domain names. It's compiled automatically by a large reputation system that continuously assesses the reputation of domains that we see in email traffic, or that we think might be in email traffic at some point in the future. And so we publish these domains, and these again are categorized and distinguished by the return code that Skull mentioned earlier. Is we have domains that we consider fully fraudulent, so they have been registered and they're fully controlled by bad guys, and the domain has just no legitimate use at all. The other case is that what also happens is that domains get abused by people who have usually compromised the website of the domain or the FTP credentials, or in some very extreme cases they might have compromised the DNS. But what they basically do is they somehow get control over either the contents of a website or the host name of a domain name, and are able to use an otherwise legitimate domain name to now host something bad, like a phishing website or a redirection website, anything like that. We include those as well, but we give them a different return code so that it is possible for the user of the data to distinguish between, okay, this domain is fully bad, and there's no chance that there will ever be anything legitimate to it, versus the ones where we say, okay, these used to be good and they're probably still good, but they just have been compromised. So it's a change in behavior of the domain, as you might say. we publish these domains, and these can be spammer websites, spammer sending domains, botnet command and control domains, malware injector domains, phishing, anything like that. Any sort of bad use of a domain name would qualify to be included in this data set. It's updated continuously, obviously, and there's one thing that makes it that's really sort of special to domain reputation and domain blocklist when you compare it to IP data sets, is that with domains you have the ability to, if you're if you're lucky, to figure out that, okay, this domain name, I think it's bad, but I haven't seen the email for it yet. So the thing is that if you want to use a domain name, first you need to buy it, and there's usually some time between where the domain gets bought and where it gets used. And if you can figure out that the domain name is bad, in that window, you can have the domain be in your data set of bad domains before it's being used. So this means that whenever you're going to get the first spam that might contain a domain name, you already have it in your data set of bad domains, which means you will be able to stop the very first spam that will have that domain name in there, and which basically brings the response time to a new campaign down to 0, because you have this advanced knowledge of the domain being bad. And this is something that we heavily focus on, is getting this the reputation for the bad domains done, figured out before they're being used, which is sort of the unique thing about domain reputation. We have another domain-based list called CRD, zero reputation domains. Now, as I mentioned, due to the nature of domains being bought by bad people and then being blocked by the good people, there's quite a lot of churn in domain names being used, and this means that there's something inherently suspicious about new domain names per se, because the people who do things right, they want to keep on to their domain name. They will protect their domain name as an asset. They will take care to make sure that their domain name is in good standing. And if you start observing DNS traffic and you start looking for domain names, you start storing the history, at some point you will have seen basically every domain name that's in active use if you just wait long enough and if you look at enough data. So anything that's new is almost automatically is suspicious, especially if it's being used in a certain way. So this data set, the zero reputation domains, is a tool that allows you to take leverage of that, say, okay, here's a set of domain names that we have observed for the very first time in the last 24 hours. The moment you see these being used in email as a sender or as a hello or it is almost certainly bad, and any mail that uses a domain in that way should be treated in a different way than what you would normally do. So that is really the use case of very new domains. There's a lot of research out there that supports this way of looking at new domains this way. And yeah, basically at this point, if you've never seen it and the first time you see it is in an email that is spammy, and yeah, you can pretty much say that the domain is bad. So the ZRD is a data set that allows you to do that. But that is not all. We can even put different things in a block list.
Indeed. And as a matter of fact, there are almost infinite possibilities as long as you can represent them in something that is small enough to be transported over DNS. And that is why we ended up creating a list of hashes in the cryptographic, as in cryptographic hash. The concept behind it is nothing new. If you look at it, the concept has been around for a very long time. what we do and what we invite people in doing is simply identify things inside the message, inside the email message that can be attached to a reputation, maybe do some normalization about them, and then generate a hash to query against us. We did this at the moment for 3 different type of data, and composed what is the HBL, the hash block list. Now, it must be said that this is just what we're publishing now. The HBL by its nature is supposed to be modular, meaning that additional components can be added anytime. Right now, what we are generating hashes for and what we're listing are mainly the 3 that you see on screen right now. The first one is email addresses, where that may sound strange because, of course, you are probably used to see a lot of forgery in the email space, but that is not always the case. There are some type of spam, I think, for example, of 419, the so-called Nigerian scammers. What you find in their messages is that they are sent by an email. That email address can be forged, it can be compromised, so it can be literally anything, and it has a lot of variation. So that's not really a good hook to attach reputation to. But since they need to be able to get in touch with the victim of the scam after they fall for it, their messages contain another email address, usually inside the body or as a reply to address in the headers, in many cases both. And that address doesn't change that often because, of course, that is the way they, that is the channel they need to keep open with victims. And if they change that address too often, what is going to happen is that they lose the capacity of being in touch with people that fell for the scam like yesterday. So if you look deep enough at this type of traffic, you will see that there is a lot of reuse of these addresses. And that is the perfect example of what ends up in the email component of the HBL. It allows you to block stuff that otherwise would be rather hard to block, as those who manage mail servers kind of know at this point. Because it usually comes from legit mail servers, meaning that an IP list is not really helpful. The domains that are inside the message and the SMTP transaction are entirely legit because, again, the content is just some text and an email address. Well, the email address is what can allow you to have a better filtering for those. Something kind of similar is the second list here, that is the crypto wallet addresses. You all think, you all know, I think, what I'm referring to when I'm speaking about extortion scam. It has been quite popular for the last few years. And for those who don't, I'm referring to emails that basically try to scare you about the fact that some hacker broke into your machine or any variation of that, and they have personal information about you that they are about to release unless you pay for it. And the way you're supposed to pay for it is by doing a Bitcoin, usually, transaction or any other cryptocurrency transaction. And for that very reason, they do include in the body of the message the crypto wallet address where you are supposed to send your money. And again, that is a link between the message itself that may come from any source that you may be able to outright block or not, with the campaign itself. So if you see a Bitcoin address in the message and you know that that Bitcoin address has been used for a spam campaign of this type, well, you are a reasonable reason to decide that the mail is no good. So this is exactly what we do. We collect these addresses as we see them used in spam. We compose a list out of them and we publish it. And I dare say that this has proved to be quite effective way to filter out this stuff. Some of our customers have been using this for many months at this point, and I would say with very good results. The last item that we ended up putting into the HBL so far is not really strange. I mean, it is very obvious if you think of it, and it's just hashes of malware samples that are sent through spam, mail spam mostly. Of course, you see a lot of that around. Of course, this type of list is not supposed to be an alternative to antivirus scanning. Actually, we do encourage people to run their own antivirus, of course, but it kind of comes for free if you think of it, just by the sheer number of data that we process. We identify a lot of this malspam. We run it through our malware analysis platform, as we said earlier, but since we see it, it makes sense for us to just put it out, because we have a very, very low latency between the time we see something to the time when that something is listed and can be used by third parties. And by a very short time, I mean something in the ballpark of a few seconds. And that means that this is an information that, even if it can be considered redundant for those who have a good antivirus protection, it can still be helpful for the timing perspective. You may end up finding the information published by us even way before your antivirus vendor managed to identify that malware and push out signatures for it. And that is why we decided to do it. And of course, this has a lot of implications in how you are supposed to use our lists. Again, if you're interested into the HBL specifically, we published a webinar dedicated to the topic in the past. So I encourage you to go back there and find it. You can find it on our YouTube channel. But the rest is just putting things together and using our block lists. And Carlo.
Yeah, so that comes to the final part of this this webinar: how to actually use this data. In basics, it really is nothing more than instructing your mail server to query us about identifiers that you see. The most obvious one would be the IP addresses, and after that, sort of the next step would be to do the same thing for domain names and for hashes that you compute. It really, that is really all there is to it. You ask the question, we give the answer, and we tell you if we think it's good or bad. And the result of that is what you do with the information. That's really in your own hands. It really is it's sort of a build your own adventure, basically. What I usually say to people is, what we do is we make Lego blocks and we provide you a blueprint that for building a really nice house. But if you want to build something different, that's obviously very much possible. It's really a very flexible data set, and to integrate into your own environment. And the things you can do with it are really only bound by the what you apply it to, and sort of the flexibility that you have in your own environment. There's basically, yeah, anything can be done with it. And that is just this is just talking about email. I mean, there's a whole bunch of use cases for this kind of data that do not have to be email related per se, but usually email is the most common use case, and that's the one that people are most familiar with. There will be once you start using the data, usually what we say is we believe that the data that we publish is good enough to if when you talk about IP addresses, to reject at the front door. Basically, the moment you get a connection to your mail server from an IP address that's on our list, we believe that it is safe enough to actually reject that message. The advantage of that is that whoever sends it will actually get an inline notification that this mail was rejected, for the reason that is listed in one of our data sets, which means that if it's incorrect, they will have a very, very clear signal that something went wrong. But we believe that that's the quality of the data set is good enough for that. But given your environment, you may want to make different decisions, and instead of blocking it outright, you might want to tag it or put it in a spam folder or anything like that. And this, so the little graph skull will tell a little bit about what kind of options there are.
Yes, of course, as Karl said, in the end, we believe that some things can be done even before inspecting the corpus of the message, the content of the message. And that is why in the very top of this graph, you can see how we do suggest doing an initial lookup about the sender that involves not only the sending IP, but also the sending domain, the hello domain, and other characteristics of the envelope part of the SMTP transaction. And you can, if you want, you are not forced to, of course, make a first decision there and maybe just reject a portion of the traffic outright, if that fits your policies, of course. And after that, you can just pass the message to a second layer of filtering that does the content inspection, the scanning, the antivirus, and other things, and so on. And of course, even there, you can, for example, extract email addresses from the body of the message and do HPL lookups. You can extract URLs in the body of the message and do DBL lookups. You can do anything that revolves around our data sets, and of course anything else that may make sense for you. And at that point, you can decide what to do with the message. And the most common scenario, you have three options. The first one is, of course, accept the message if you see nothing wrong with it and deliver it to the mailbox of the user. The second one is reject the message so that the message basically never really enters the recipient mailbox and is sent back to the sender, or better said, refused entirely. And the third option is, of course, tag it and maybe deliver it to a junk folder inside the mailbox of the user, so that the user can later inspect it and maybe take it back if he needs to. And in the end, that's the point. You can use scoring system, you can use tagging, you can use a junk folder. It's really up to you, or whoever manages the email system in your environment. And I think this is about it.
It is indeed. Thank you, gentlemen, very, very much. We're just going to move now onto the Q&A session. So without further ado, we've got a great question here. Could you possibly shed some light on consumption of DNSBL feeds in non-mail server scenarios? For example, it's been observed that if a certain IP is blocklisted, web browsing and other services or apps like online meetings and screen sharing apps also don't work, or they're severely throttled when using it as a source IP. Could it be due to edge security solutions at content providers' ends that are using IP reputation lists to throttle or block connections from such IPs?
If you don't mind, I will pick this up. It may be. Again, it's up to whoever consumes our data what to do with it. So yes, these are all valid scenarios that where our data can be put into play, but that has a lot to do again with what are the policies for our lists. So if you remember, we said that the SBL also lists command and control servers. And you should understand, I guess, that if you are able to block the communications between your network and all the known command and control servers, so you're basically rendering any bot that relies on those incapable of operating from your network. And that is something that a lot of people do with good success. And that is also why, for example, we do publish for some of our customers in the security industry a subset of the SBL that only contains command and control servers, exactly for this type of usage. But as we said, DNSBL, meaning consumed through DNS, is only one of the ways to consume our data. It's by far not the only one. For example, what we do with the XBL, that again is about compromised IPs, is produce and publish to our customers a version of the same data that includes that is enriched with a lot of metadata, like for example the timing of when we're seeing something, what we have seen, that is how the detection happened, and also what we think we observed. And with bots, with compromised machines, that means mostly what type of botnet they are a part of. And this allows customers to do correlation about their environment. For example, if they run web services, what they may end up figuring out using our data is that some attacks that they see on their platform, some abusive behavior they see on their platform, is strictly correlated with IPs that are infected by something, whatever that something is. And if they are able to make that correlation, that allows them to preemptively apply some limitations to IPs that are known to be part of exactly the same botnet that is attacking them. And of course, I cannot say what they do. Again, that is entirely up to the individual customer, but it's certainly possible, and it's one of the ways to use our data. I hope that answered your question.
Thanks for that, Skull. Carol, could I just ask you to go to the next slide, please? That would be super. We have one more question here, which is, what type of block list should you use at the SMTP connection? Is it just IP block lists that should be used?
I'll take that one. No, I think you should also use the domain-based ones at that stage. If you look at that early in the connection, one thing you can already do is you can look at the reverse DNS of the IP that's connecting to you, and that reverse DNS will usually have a fully qualified host name. So you'll have a host name part, you have a domain part, you have a TLD, and you can look that up against our domain data set, and that will give you an answer. And so that's another way of finding out that that an IP might be sending bad mail. You can do the same thing for the hello part, which is also part of the early STP conversation, when the server that connects to you issues the hello command, and that is usually followed by a host name. And so again, that host name can be checked against the domain-based data set. So this goes both in the cases that I explained earlier. You can both check that against the normal domain block list, the DBL, but you can also check that against the CRD or any domain-based block set. But yeah, I would definitely include domain-based block sets in that early stage.
Okay, thank you. Well, if nobody else has any questions, I'd like to thank you all for joining us, and enjoy what remains of your day. and we look forward to connecting soon. What I will do is, Skull mentioned about the hash blocklist webinar. I'll include that in the email that we send out to you with this webinar link as well, just so you have it for reference and you can easily find it. So thanks again for joining us all, and we look forward to connecting in the future. Many thanks. Bye.
Thank you, everyone.
Thank you. Goodbye.